Hi and welcome to video 5 of our PSMT guidelines. In this video we're going to talk about the third criteria, evaluate and verify. So let's skip to it now. Okay, so here's our criteria for evaluate and verify. You note that formulate has 4, solve has 7, evaluate and verify has 5 marks available. 4 criteria bands, and you'll see again we're not going to talk about the 0 and 1. Now again, it's not too hard. It's a little bit more of a stretch than the last 2 benchmarks I set, but it's not too hard to reach a 3 here. To reach a 3, you need statements about these 3 criteria. Again, we do see often students will submit solutions or submit tasks, but they haven't actually discussed one of these or 2 of these or sometimes all 3 of them, which really shouldn't happen. They're right here for you. They're on the PSMT marking guide, and you know exactly what you need to do. So they are, first dot point, reasonableness of solutions. The second dot point, strengths and limitations, and the third dot point, justification of decisions. And you remember earlier that I talked about the fact that reasonableness of solutions and strengths and limitations we typically see as part of the end of a task, maybe just before the conclusion, whereas justification of decisions we often see happen throughout the task. As you make a decision, you justify it. But I'll talk about that in a bit more detail. Before we do move on to each individual one, let's just have a quick look at the language so we're ready for that discussion. So the first one is evaluate the reasonableness of solutions. The second 2 to 3 band says statements about the reasonableness of solutions. So there's some information there. The first one also includes a reference to assumptions and observations, whereas the second one doesn't. So just keep that in mind as we move forward with this. Documentation of relevant strengths and limitations. We've spoken about documentation. And then statements about relevant strengths and limitations. So there we are again. And justifications of decisions made using mathematical reasoning, or statements about decisions made. So there's a difference in language there, as you can see. And of course, that one criteria is just a statement about a decision and or a statement about the reasonableness of a solution. So first of all, evaluate the reasonableness of solutions by considering the results, assumptions, and observations. What is required? Specifically, we need to consider referencing some assumptions and observations with clarity. Don't just throw them in and expect us to find them. Say, with regard to assumption 3, you can see that our solution is reasonable because. So you've referenced it, you're providing information, you're giving your your explanation. Do that with assumptions and observations very specifically. And confirm that your results are 1, what you expected, 2, suit the context of the task, 3, match the mathematics applied, and then if you're considering your assumptions and observations as well, then you'll be able to generate a good discussion about the reasonableness of solutions. Question to consider, is it what you expected? Does it suit the context and contextual domain? So that domain is, if we're talking about house prices for the next 10 years or the last 10 years, does it suit the last 10 years? It might not suit house prices 100 years ago, but does it suit the last 10 years? Is the answer numerically approximately what you expected? So you can discuss that as well. And you can discuss that with reference to graphs as well. So if you're making a prediction from a model, that is a function that fits some data, you could look at the graph and go, well, I can see it's about 1,000, and my calculation gave me 997. So I'm happy with that answer. And you got to refer specifically to assumptions and observations. The second criteria is strengths and limitations. And I'm going to give you a few tips here that help you set this off. It depends task on task, but there's a couple of little things that always will pop up. Firstly, a reminder about documentation. So remember that documentation is a statement with evidence. So we're making a statement about what our strength is, and we're providing evidence, and then it's documented. Similar to our assumptions and observations, you really need to document over 50% of your strengths and limitations. We can't put a number on it, but typically you might see 3 strengths and 3 limitations or somewhere around there, depending on the task. So strength is something that you have in your task that you've done or that's part of the task that improves the accuracy of your results and the reliability of your results. So for example, you've collected a large data set, or you've managed to refine and remove certain assumptions. You've got a good R-squared value, or your algebraic solutions fit nicely. We haven't got a strength of I did my calculations correctly or I used an online solver. They're not really strengths. They're just tools that you used. Limitation are things that affect the accuracy and reliability, certain things that you can't fix and you're limited by. So the opposites, essentially. Did you use a big set of data? No? Well, then you used a small set of data and you've got a limitation instead. Assumptions that can't be refined, or assumptions that have a significant effect that you can't fix. Models that are not mathematically reliable, so low correlation coefficient. Again, you're not limited by your knowledge or the fact you have this task is related to a chemistry context and you don't do chemistry. So you leave those things out. Limitations also considers domains and ranges for the situation. So when I say that, I mean if you're collecting data on car prices for the last 10 years and you decide to pick a particular car, so you're going to do a Toyota Hilux, that's fine, but then all of the conclusions you make are relevant only to Toyota Hiluxes for the last 10 years. And every other prediction you make is limited. You couldn't use that information on Toyota Hiluxes and then go back and use it on a Datsun from the 80s. Because it's a different set of data, things are different, the car's different, so you're limited. The model that you've created, you've restricted certain input data, and therefore you've got some limitations there. And I would always be starting my limitations at that point. Whereas both of them, you might be able to provide a strength, that is that you have a good R-squared value, and you can talk about that. So limitations and strengths, again, I would probably encourage you to use a table or dot point list, but it's really up to you how you approach it. You do need to talk about your solution and or model. So let me talk about that briefly as well. A mathematical model is any time you use mathematics to create a tool that represents the data or the information or the situation. So the most common ones are, as soon as you collect, in general maths, you're going to see two things. You're going to see probably statistics, where you build a mathematical model. It's your graph. It models things, or maybe it's the linear regression line. That's a mathematical model. Or another one will be a financial situation, maybe where you build a budget. That budget is a mathematical model. You're modeling the data so that you can make predictions and you can do things with it. In math methods, it's probably more going to be about collecting data and building a function that fits that data well. So maybe a quadratic for projectile motion. That's a mathematical model. And your solution is the actual answer that you get back. Now, your solution and the comfort level of the solution is something you'll discuss. Strengths and limitations. Here's 8 things that we sort of discussed that come up, but it's certainly not an exhaustive list. You may talk about strength limitations that arise from a range of things, such as visual solutions, numerical results, mathematical procedures, your choice or decisions, graphical representations, theoretical understanding, the context, or your research and sources. There's a start, some things to think about where you might be able to draw some strengths and limitations from. Justification of decisions, the last one, justification of decisions, made using mathematical reasoning. So throughout the task, every time you make a significant decision, explain why. For example, I will collect 30 samples of data as 30 represents 10% of the population. You've justified a decision. Have you used mathematical reasoning? Maybe not quite there. Maybe we need to go and actually find a reference or a reason why 10% is important. But we chose 30 and this is why. I will use the initial point and turning point to determine my quadratic model in transformational form, as the context relies on quadratic motion, and these two values provide enough information already. So we've got, they're the ones that are given to us, therefore we're going to use that. I'm choosing to share my rental property with 3 friends. This is a budgeting task, as I cannot afford the property alone, and this allows me to split up some of the living expenses. So you might then put into your task, split shared accommodation, 4-bedroom house divided by 4, and that's a decision you've made, but at some point you need to explain why have you made that decision, and this is what this does, what it covers. So just make sure that as you make a decision, that you also justify that decision throughout the task. Well, that's the end of this video. Thanks for watching.